Let's have a look at bolted connections, and we'll talk about three different things in this lecture. We'll look at the grades of bolts, bolt strength. We'll look at a special kind of bolt called a tension control bolt, and then we'll look at two kinds of bolted connections used in structural steel. So first, bolt grades. There are two different systems for standardizing the grades of bolts. One system uses SAE, I'm going to tell you what that is, and one system uses ASTM, and they are all put together here in this table out of Machinery's Handbook. There are lots of different grades of bolts. We'll just look at the ones that are most common. Beginning with SAE. And SAE stands for Society of Automotive Engineers. They standardize all kinds of mechanical things that are used in automobiles and trucks and off-road vehicles and airplanes and all kinds of vehicles. If you buy a can of oil, you'll see it says SAE 10 weight 30, for example. Well, they standardize bolts. And here is the bolt chart for the three most common grades of bolt. And you'll notice here in this chart, it lists the minimum strength. Notice here it says these numbers are in 10 to the third psi. What is that? That's 1,000. So over here, if we look at the yield strength of the bolt, a grade 2 is 57,000 psi. A grade 5 is 92,000 psi, and a grade 8, the strong one, is 130,000 psi. So grade 2, those are sometimes called butter bolts. Those are just your garden variety common bolt. Grade 8 are the really high strength bolts. And you can recognize what grade of bolt you have by looking at the bolt head. It's marked in these raised lines. In structural steel, the bolt grades are standardized by ASTM. And ASTM formerly stood for American Society for Testing and Materials. ASTM writes standards for how strong a particular material must be, and then the test protocol for proving that your particular bolt or material is the strength it says it is. It's become a global organization, so it's now just called ASTM International. And here are the three grades of bolts that are used for structural steel. Here's a page out of the Steel Detailing Manual. The first grade is called a common bolt. It's equivalent to the butter bolt over in the SAE kind. And then there are two grades of high strength bolt. And you can tell what kind of bolt you've got, again, by looking at the bolt head or the nut in this case. So they are all marked with what kind, strength grade that bolt or nut is. So there's no danger of going the wrong way, because structural steel, this is really important in high-rise buildings. Now, the world of structural steel is different from any other kind of drawing that we do. In steel detailing, if they're really doing high volume production drawings using formal steel detailing standards, they'll use an open diamond to represent something that's bolted in the fabrication shop, and a solid circle for something that's going to get bolted out in the field. That open diamond, that shop bolted, is a common bolt. That's the low strength grade of bolt, and it's used for temporary holding. For example, in a steel fabrication shop, they might temporarily bolt an angle clip onto the end of a beam just so they can ship it out to the job site. And out at the job site, that angle is still bolted onto the beam. Now the steel worker can weld the thing on permanently, or can take out the common bolt and put in a high-strength bolt. In the high-strength bolts, there are two grades there are subgrades. There are two grades, and the most common is this A325. There's another kind of bolt called the tension control bolt that's pretty interesting. It uses a special wrench and a special kind of bolt. And notice that the end of the bolt has they're like splines. They're parallel teeth on them. And so the wrench grips both the nut and the bolt, and using compressed air turns the thing. And these bolts have a narrow place where that splined end hits the threaded part that is calibrated to shear off at a particular stress level. So the wrench grabs the bolt in the nut, it turns the threaded nut, and when it reaches a particular stress level, it stops, and then the other part keeps turning that splined end of the bolt, and when it reaches a particular stress level, it reaches ultimate stress, it just fractures, it just shears off, the end falls off, the wrench pops off, and you are left with a bolt that has been permanently bolted. And the bolt head, as you can see here, it's not like a hex bolt. You can't put a wrench on it and retighten it. You can only tighten it with this special tension control wrench. So it's shear stress that makes the end of the bolt fall off. Finally, I want to show you two different bolted connections that are commonly used in structural steel. Here they are, the framed connection and the seated connection. There are some others, included single plates, but I just want to show you framed and seated. A framed connection uses what's called a framing angle, and you can see framing angles pictured here in this drawing from the detailing manual. A framing angle bolts or welds to the end of a beam or the middle of a column, and it's the bolts or the welds that hold up the load. And these things all come in standard sizes, so a fabrication shop can just quickly get the right size of angle and make 1,000 of them. The bolts are always 3/4 of an inch in diameter, and the bolt holes are always 1/16 of an inch oversize. So in other words, they're always 13/16 diameter. That means the fabrication shop can get a punch and punch a whole bunch of holes in a whole bunch of beams real fast. Then these framing angles and the bolt holes they connect to are always 3 inches apart, and it's always 1.25 inches from one bolt hole to each end of the framing angle. So that means your fabrication shop can set up some fixtures and punch holes in framing angles, again, real fast. And that's important because when you're building a high-rise building with a structural steel framework, you have thousands and thousands of pieces of steel. And time is money, and every second counts. So that's why all these pieces are standardized. So these are framing angles. Finally, the other kind of connection is a seated connection, and it's called because the beam sits down on this seat angle. And you might be able to tell from looking at this drawing that the seat angle is thicker than a framing angle because it actually has to hold up the weight of this end of the beam. Then the beam is either welded or bolted to the seat angle. And up at the top is a thinner angle. It doesn't really do much. I mean, it's not holding a weight. It just prevents moment. It prevents the beam from twisting and rotating, and so that could be bolted or welded. Erection crews like these seated angles because, well, and so do fabrication shops. They're easier and faster to fabricate. Notice we don't have to punch any holes for framing angles. We just punch one hole or two holes for the seat angles. And then out on the job site, we don't have to be doing a whole bunch of bolting. So it is faster and easier, and the erection clearances are easier to maintain.